Okay, everybody, good evening. I think most people that I see in the chat are from India and some from Pakistan. So pleasure to have you. Welcome. I think we have a nice hour ahead of us. We'll discuss artificial intelligence from quite some different angles. We'll start with basic definitions, of course, and then we'll look at the market and how that market is developing and what the use cases could be, right? And then we'll dive into the technology a little bit. No Python, no scripts, right? Nothing like that. I think that's too far for a session like this. And then we'll end with what's coming up next in this whole game of AI. So before we dive in, let me do a quick intro. So some of you may know me, and others I think it's the first time. So my name is Rens. I'm the CEO of Kimo. Kimo is a Dutch edtech company that is now rolling out slowly in India. So I'm dialing in from the Touch Hotel in Bangalore. I'm flying out in a few hours. And we teach the latest new age skills, right? So AI, Web3, blockchain, metaverse, etc. I normally live in Amsterdam. I have a beautiful wife there and a 1-year-old daughter called Julie, who's amazing. And I'm happy that I can see her tomorrow again, of course. And my previous experience is at McKinsey as a consultant and as an advisor to the G20 on tech and on climate, right? That's enough about me. I think let's jump in. So maybe as a start, how much do you know about AI? I saw a couple of people already saying that they know nothing, so they're completely new, but maybe give me an answer on the chat, 1 to 10. What's your current self-assessed knowledge? So what would you say that you know about this? I see 8s, I see 2s, lots of 5s, 6s, 8. Okay, so I think we've covered, no one has said 10 yet. But I think we've covered the entire spectrum, right? So maybe someone is smart enough in the audience to do the average. Lots of 2s. Okay, so maybe I think if I have to do a quick average now, I would say we're at 5. Arslan is now, of course, saying 10. I could expect that. 2.5. Mia is very, very precise. Okay, great. So we have lots of different people in the group. I also guess you come from different backgrounds. Right, so I'll try to do it in such a way that everyone will get something out of it, because we'll cover a couple of different perspectives. And the initial association with AI, especially if you're new to this, and I typically also do this with executives, right? So what do you think about if you think about AI, right? And if you're not an engineer, this typically comes down to something like this, right? So what is AI? It's some kind of force that will take over humanity. And why is that? Because in every Hollywood movie about AI, that's typically the script, right? So it's almost always the same thing. Some kind of smart guy starts producing some code that becomes intelligent, and then that script in the end takes off and is uncontrollable and takes over humanity. So that is the thing that, yes, recommended, watch those movies, lots of fun, but it's not the thing we're going to do today, right? So what is the better perspective? What's the actual market? What are the actual economics? So what are we trying to sell here? What are we trying to build? What's the technology like? And then finally, also a bit about geopolitics and how everything is shaping up globally, because of course, this is a big game between China, maybe India, the EU and the US, right? So everybody's trying to build the best models in this space. So let's start with the basics. So very simple definition. What is AI? What is artificial intelligence? Of course, that is the digital version of our biological intelligence, right? So the goal of AI is to match or maybe surpass human level intelligence in software, right? So that is the game. And already there's lots of debates whether we should try to match human beings or whether we should try to surpass human beings. I would say surpassing human beings in specific areas is probably beneficial. If you look closely at what intelligence means, right, in general, that is a multidimensional thing. There's not one thing, right? There are lots of different dimensions in these intelligence tests. And I think that the areas where AI so far has been successful, memory, you know, your computer has better memory than you do, language, vision, creativity, until a little, at least for a bit, goal-driven behavior and movement. So there we've made some successes, but there are lots of areas still in human cognition where we have made no successes whatsoever, right? Consciousness. If you believe the Google engineer that left, right? He believed the Palm model was a conscious model, and then he got fired. But typically we assume AI is not conscious. Compassion, AI does not have compassion. It does not have emotions. It does not have ethics. it cannot handle multiple goals, right? So like human beings, we have to decide lots of different things, and typically these goals compete with one another. That is not how our AI system works, right? You optimize for one specific result, and it doesn't have any general intelligence. So it typically cannot do more than one thing. So maybe it's good in language understanding, or it's good in classifying cats and dogs, but it will not do all of those things at the same time, right? So the end goal is surpassing or matching human level intelligence through software. But if you look one level deeper, you can already see that lots of things are complex under the hood. AI is typically framed as a stack, right? As an overarching category where it's about, as mentioned, the digitalization of cognition of human intelligence. And underneath that, you have different subcategories. You have machine learning. Machine learning is the overall category where you build algorithms that are typically predictive and that improve through exposure to new data, right? And the alternative would be that you code again every time. This is a different thing. You code it once and it actually gets trained with new data and gets smarter by the exposure of new data. So that whole thing is called machine learning. It sits underneath AI. Underneath machine learning, you have something called deep learning, which is very popular today. So deep learning is everything that relates to neural networks. And neural networks are, of course, modeled after the neural networks in our brain. And then you have lots of functional specialties, right? You can go into language, natural language processing. You can go into vision, think autonomous cars with cameras and automated detection of other vehicles, of signs, of bicycles, etc. And of course, now you get the first model, and we'll get back to that in a bit. That can be multimodal, right? So the first models are now appearing that can do both vision and language at the same time, which is quite new. But typically you had these functional categories, and knowing your stuff in natural language processing used to be with RNNs, for example, and then LSTMs, now it's all transformers, right? So different architectures. That did not mean you actually knew how everything would work in vision, because these were like functional specialties. Okay, in the deck, and don't worry, this slide is terrible, of course, to present, so I'm not going to go over all the vocabulary here, but I'll make sure you have it. So if you want to go deeper and you want to understand like all these specific elements, I'll put a couple of slides in for you so you can go into the all the words here, but that's for later, that's not for now. Let's look at the market, right? So one of the best ways to understand anything, in my view, is if you follow where the money is going, right? Because where the money is going, that's where people are buying something. And if they're buying something, there's value creation. So a smart way is just follow the money and see what is actually happening. And if you do that, you start with a very, I think, very unique insight. And the slide is a bit complex, but I'll give you the overview, right? So AI has the potential to add 13 to 15 trillion US dollars to global GDP. Right? And what does that mean? Well, the global GDP is roughly 90 to 100 trillion, right? So we're talking a single technology, a single set of tools that can add 13 to 15% in global GDP. That is quite unique, right? And then so what are other technologies that did that? Maybe electricity, right? Maybe automotive, right? Piston engines, but you have only a few technologies that have so much impact that the entire world economy will change because of them. And the reason it's that impactful is that AI is what we call a general purpose technology. So it's not something that you can only use in an autonomous vehicle, or that you can only use in your phone when you're speaking to Siri, right? Or that you can only use for cats and dog classification. It's very similar techniques. Of course, the actual infrastructure is a bit different under the hood, but there are similar algorithms and similar training methods that you use for all these use cases. So AI does not impact one industry, it impacts probably every industry. And if you look at where's the value, where do we really see the big chunks of value in this game? I would say if you summarize this chart in a very simple statement, there's a lot of value in understanding users, understanding people. So on this purple chart, you see what are the big chunks? Customer service, right? Offering new products to people, recommenders. You go to Amazon, you buy one coffee, and then the next thing it will recommend is a coffee machine or whatever, right? So recommending things, all that relates to understanding users better, doing user analytics, doing behavior analytics. And that is typically customer service, marketing, this kind of stuff, and sales. Then the second big chunk is on the other side of the value chain, and that is manufacturing. So that is everything we produce in large factories that goes through a chain of optimized value creation. We have other sessions on that. Those are very expensive, very big machines that actually run for us. And if you look at, for example, here, this very big chunk of value is predictive maintenance. What does it mean? It means that if you have 100 robots in your factory, you want to know when one of these robots is going to break down, because if it breaks down, typically your whole factory needs to stop, right? So you cannot have that downtime. So ideally, you know when everything is going to break down before it breaks down. You want to know about your airplane failure before it comes down, right? So you can fix that, and with that have more uptime of your factory or uptime of your airplane. So it's those kind of use cases, very different, right? Some are very clear. User analytics, I think most of us will know Google Analytics or something like it. But the other side is really the how we make stuff chart, right? So general purpose technology, lots of value, it can be used for lots of different industries. Of course, it doesn't mean that everybody will have the same amount of benefit, right? So if you look at the projected benefit in different countries, then what stands out to me is that the projected benefit for China is by far the largest. And then the second one is the US. Is that a problem? I think so, because ruling this game in AI is going to give you lots of opportunities. And falling behind in this game is also going to have lots of consequences. So why are these countries ahead, or why do we think they will earn more in this game than other places? It comes down to a couple of things, right? It comes down to, is this a national priority? Can we very clearly state that this country is going to win this race? If that's the case, does it have the funding to actually excel? Does it have the ecosystem with investors? Think Silicon Valley, where if you have an AI pitch, you can probably raise money in the market because there's so many investors around. And does it have specific laws and clarity on laws, for example, around data pooling? Can I store all of your data points, or can I only store one data point and the rest is restricted, right? And we know, for example, China is more loose in that sense. So it's easier to store lots of data, and that makes it easier to make better models. And in Europe, we are typically more privacy sensitive, right? So it's these kind of things that influence these projections, and every region is going to benefit from this, but certain policies can make that larger or smaller. The same is true in different industries or sectors, right? So if you look at where's most of the money going to go, as already discussed, manufacturing, very important, services, sales, marketing, those are bigger than certain other industries. So it depends on where you work, how much you will notice. As a market, I'm not sure how many of you here have a finance degree or a consultancy degree, right? But if you just analyze the market, for me, software is always a nice reference point, because software is a classic market where if you succeed in software, it's fantastic. And AI is largely a software market, right? You can of course, you can sell multiple things in the AI space. You can sell APIs. You can also build AI hardware, like AI specialized silicon. We'll show that in a bit. But mostly this is a software market, and software market means that, if you build a good product, it's very scalable. So typically these products have quite high gross margins, so they can be quite profitable. Of course, you need lots of R&D for this, but the AI market is quite special. It's still an upcoming market with lots of brainy people in this space. So a lot of this is also open source. So if you're a bit smart and you know GitHub and you know how to get good data sets online, then you'll find there's lots of papers, around 15% or so, that has open code. And there are lots of Google collaboration notebooks. There's lots of Jupyter notebooks. There's lots of stuff you can download and learn because it's actually open, accessible, right? And the same is true for most of the libraries you would use, PyTorch, TensorFlow, whatever you prefer. But lots of those things are really well quality or high quality, and they're open source, right? So very interesting space. Yes, you can make a lot of money, typically in software, sometimes in hardware if you have a lot of funding. But at the same time, it's a very intellectual sort of research space. And on archives, you can find millions of papers, and quite some of those have open code. Then the startup market. So Chemo, for example, is a startup that has been funded in the AI realm that you see here, right? So you can see how this market came up. In 2011, there was almost no funding in AI. Now we're in 2022, and the funding has grown 58% year on year, right? So very, very large increase in funding. And with that, I have a question to you. So curious to understand how well you understand this market. So what is the most valuable AI company today? So it should be a simple, if you care about AI, this should be a simple question, but put your answer on the chat, please. So what's the most valuable AI company today? Tesla, Meta, Google. Yeah, so I think it depends a bit on when you think the company is an AI company, right? Google, Amazon, Chemo. If only. OpenAI, Apple. Okay, so maybe I should clarify the question a little bit, because I think not all these companies. So some of these companies, all of these companies use AI, right? So I think no one is completely wrong except the person saying Chemo, because that is definitely not in the most valuable companies at the moment. But it will be, of course, in the future. But the company I was looking for that is really run by an AI algorithm, pretty much, because of course you can say Tesla has cars and there's AI inside the cars, fair enough. And Google has search, and search is mostly AI driven, so very much an AI driven company. But I was looking for younger companies, and in particular this one. So don't be offended if you said Google or Tesla, because you're also partly right. But if you look at what are the upcoming very much AI driven companies with the highest valuation, then ByteDance, I would say, there is number one. And ByteDance is the company behind TikTok, right? Why is that such a good company? Well, it's actually very smart if you think from the AI perspective, right? So what does AI do? AI does predictions. It tries to predict something, for example, the video that you want to watch next. And TikTok is a company that, of course, I guess lots of you will have that application. It has very short videos, right? And short means that you get quite a lot of data going back into your system, because every 10 seconds, 15 seconds, however long that takes, the system will collect new data, whether you kept watching, how long you kept watching, whether you swiped, etc., etc. So very smart system, 2.6 billion downloads in the last 2 years, right? So this is the fastest growing app in the history of apps, and it's completely AI driven, right? So nice example of how that could work. This is something that is a bit more reflective, and I hope you can appreciate the slide. But what I want to say here is that how does value creation work in the AI space, right? It works a bit differently than a linear thing where you just, for example, if you're building a house and you put 5 new bricks every day, then at some point you can predict when it's done, and the value creation is very linear. And here it's very different, right? In AI, typically you need lots of R&D. There's lots of stuff happening behind the scenes that you will not know, because it will happen in large data centers with lots of PhDs trying new models. So that whole R&D phase is the slow phase here in the beginning, where new things are invented. You will never learn about it unless you are really in the middle of that game. And then suddenly there's a tipping point where this starts to become useful. And the real tipping point is when these models become better than human beings, right? Until the point where these models are worse than human beings, the value is typically pretty low, because we will probably ask humans to do it. Think about driving cars. If the AI is not better than human beings, then it doesn't make a lot of sense, right? We'll have more accidents, more people will die in traffic. But once they get significantly better than human beings, then it's almost the opposite. Then you could argue that, you know, if less people would die with autonomous vehicles, you should probably have autonomous vehicles on the road, right? So the tipping point is when the AI models get better in the prediction than the human being. In some areas, that's already the case, right? In quite some areas. So one classic example is skin cancer detection. So you could go to a doctor. The doctor could classify essentially, is this cancer, is this not cancer, looking at the spot on your skin. But if you give this to the AI system, they are typically better than the average doctor, right? So almost from an ethical perspective, you should be checking that at least as a doctor. So very different market. It will be hidden for a long time, and then suddenly it will be on your phone, and it will have a lot of impact, right? Same with translations now. A few years ago, it was very difficult to translate. Then suddenly you had Google Translate, and it started to work. And now in the last weeks, you have models that can translate in 200 languages instantly, right? And the next version, which Google is now showing in the new Google Glass, is instant translation that shows up on your screen, on your glasses. So you can actually speak to the person, get the translation in real time, right? In 200 different languages. So you can see how quickly then that might move the needle. Another sort of reflective chart for those of you in markets and in predictions, right? So the growth rate in technology in general, specifically in AI, is way beyond the growth rate in any other market, right? So if you come from real estate or e-commerce or whatever space that you come from, the growth rates are typically quite low. E-commerce actually also, of course, in AI space is quite high, but let's say normal retail shopping. So normally you model something with like 2 or 10% per year, right? Same as, for example, inflation or a bit beyond inflation. And this kind of space tends to grow now at 100% per year, right? So language models, for example, they improve at 100% per year. So every year they're twice as good. And that's a super fast pace. And that means if you want to keep up as a professional, you cannot use books that are 2 years old, right? You cannot use books that are 5 years old. You cannot have a school curriculum that is 20 years old, because literally you're learning something that is completely prehistoric, right? So in the AI space, you need the latest stuff. If you're now in NLP, you need to learn transformers, right? You should not learn RNNs and LSTMs and all that kind of stuff. So it's very important. This space goes so quickly that it's not like the markets that you know. So you need a different way to stay on top, right? You need real-time information, the latest code, the latest models, etc. And at the same time, we see in society, and this is, I think it's a fun chart, you can see the adoption rate, right? So in every 100 people in society, you can see how long that took. The chart is a little bit unclear because of the colors, but the trend, I think, is quite clear. In the past, if you launched the radio or something, it would take you almost a full decade to get it in every household, right? Now, if you launch TikTok, you'll have it almost globally available in 2 years, right? Unless it's banned by some government, but otherwise it will be available. So next to this development speed going really fast, this adoption speed is extremely fast. And why is that? Because we all have devices in our hands that can use this right away, right? So very different game. If you have the right kind of system, the right kind of e-commerce, the right kind of video platform, think TikTok, then it can actually sort of hit the roof in a very short time. But of course, policies matter, right? So if your country does not permit TikTok or does not permit Amazon, it's a different story. But the speed of change in technology is quite extraordinary, and the speed of adoption is also extraordinary. And that's why things feel like they can change overnight. There's also a hidden market here. So there's a market that, and this I think is my last market slide before we go into more of the technology. There's a market that you are probably not aware of, but it's really relevant in this space, right? So if you want to have AI models that work well, then most of the models nowadays are still supervised models, right? So you have supervised learning, unsupervised learning. And supervised learning is a branch where you need labels. You need human labels on examples, and your system will train. It will learn from the human labels, right? And it will calculate the error in the model and then improve itself. But human labels can exist in many different ways. It can exist in text. So maybe you're trying to find skills in a resume, and humans will label those skills. Or it can be for your autonomous vehicle, where you need to have all the cars and other vehicles labeled. Or it can be in satellite photos, where you want to find all the swimming pools in Amsterdam, for example, right? But all of these things are labels, and they're always provided by human beings. And this space is what we call the new blue collar work. So it's the new work that is low paid work that you can give to large groups of people. You have that in lots of emerging markets already, where you have sort of labeling factories where people actually do the labels. And if you've ever done that Google thing, you know, if you need to log in and you need to identify cars or identify traffic lights or anything like that, that is labeling, right? That's a labeling job that Google is giving to you. Under the false pretext of you need to identify as a human being. But that's a labeling job that you're doing to make autonomous driving better, right? So this is happening under the scene. It's out of sight, but there's lots of people involved now in labeling things so we can train AI models to perform. Let me quickly look at Q&A, see if there's any questions. Yeah, so Ariba is saying, so I mean, a medical student that want to know its application in the field of medicine. So Ariba, there's hundreds of applications in the field of medicine. The most fun one maybe is to discuss is AlphaFold, right? So AlphaFold is the latest model by DeepMind that is able to predict how a protein should, so literally the atomic structure of a protein. That is a massive revolution also in healthcare. But the simpler things are things like, skin cancer detection, lung picture detection. So everything that a doctor would classify, would understand, is this cancer or not? Is this a tumor or not? All those classification tasks you could theoretically give to an AI. Yeah, so smart question here. There's a lot of controversial thought about AI that will take over jobs, such as cashier, and thus resulting in more unemployment. What is your opinion? I'll try to give a nuanced opinion because it's a very complex topic. So I think in general, what we will see is a world that is more bipolar. So where you have people that are really in the top, and you have people that are really in the bottom, and the middle is a bit more empty. That's my fear, and that's already happening. You can see it in some countries like the US very, very clearly. And in other countries like the Netherlands, it happens more slowly. But my fear is that we move from this tube where everybody could be anywhere to a more bipolar situation. And that relates to how AI will impact that, right? So technically with AI, you can automate lots of things. And if you compare or you combine AI with things like RPA and with robotics, then it becomes, of course, more powerful. But not every job is economically sensible to automate, right? So, and the classic case there is car washing. So if you go to Mexico or, for example, everywhere in South America and you stop before a traffic light, then people will come and clean your car, right? And it takes whatever, 50 cents, or it's very cheap. So could you automate that? Yes, of course, you can make a car washing factory, but it's not always sensible. So in lots of these places, they don't do it because it doesn't compete with human labor. So you can have the opposite thing. You can have the situation that the lowest paid jobs are not automated because it doesn't make sense economically to automate them. And therefore, the push will be to automate the higher paid jobs that are, of course, still mostly the repetitive parts of those jobs. So my view is, yes, there is a sort of a need to escape the general bipolar situation. And yes, AI will automate some jobs. But at the same time, I also think AI will create lots of jobs. And especially, of course, if you're in this call, so you're early and you educate yourself in this space, there's lots of opportunities. And so there's a plus and there's a minus, and I don't know the size of those two things. If I want to start learning AI, where should I start? My tip would be start with some overarching things like this webinar, right? Where we will teach you the basic logic behind it. What is it about? What is the market? What's the key technology? So you start on that level. And then you start maybe learning Python. Python is the main language used today, most popular language. There are different languages. R, for example, is also quite useful. And I would try to code, and there's lots of different Google Colab notebooks on the web, right? I would try to find one that just has some basic neural net classifications of cats and dogs, this kind of stuff. And there are millions of those on the web. And try to see how the code is written and train it. Typically, it runs on Google Cloud, and you don't have to pay for it, right? So you start with getting your head around the topic, then go to some basic code. If you like it, then you go into very specific codes, first on Python and then on probably on deep learning. And then maybe later, if you want to continue on natural language processing, computer vision, or reinforcement learning. Let me continue because otherwise we won't make it through the entire session. So technology, right? AI is the main technology we're discussing, but it's not the only technology relevant here, right? So AI is actually sort of in a marriage with a couple of other things that are happening at the same time. And you should see this as parts of the puzzle. If one of these drops out, then your whole system will fall apart, right? So one is that everything, of course, is now moving to the cloud. So you have these big data centers with lots of compute power, in some cases, lots of storage, right? That are actually running most of the stuff. And why is it relevant? It's relevant because if you do something on your phone or you do something on your VR, AR headset, part of the computation will actually be done somewhere else, right? And we call that split the chip. So you have a system that is pretty light, you can carry it around. And why is it light? Well, because some of the hardware is actually in a different place. So cloud, extremely important. Of course, data, very important. Data is, of course, the ingredient you use to train AI models. How do you get data? For example, through sensors. So IoT, Internet of Things, is the sensorization of the items we have, right? Whether those are lamps or those are smartwatches or those are phones or factory floors. So that is putting sensors into everything that produce signals, which then is the data for your AI model, right? So all those things together make this ecosystem that we're creating. This is an example of a data center. This is Google's data center. These are TPUs. And the cool thing here is that these TPUs, compared to what we used before, you have CPUs, you have GPUs, you have TPUs, right? So these kind of processors are getting smarter and smarter and smarter, specifically for AI calculations, which typically are matrix calculations, right? So you put a lot of data at the same time, a tensor, through this computing stack, and it should do that very quickly. And this is all modeled after gaming devices like PlayStations, right, which have typically GPUs. And the latest versions now are TPUs, and they get more and more efficient. So you'll find as a consumer that everything will get better from here on. And why is that? It's not only because the models get better, but it's also because the hardware is now getting AI optimized. So your next phone, if you buy a Pixel 6, for example, has AI optimized stuff. If you buy the next iPhone, it has AI optimized stuff. So the language recognition, if you talk to Siri or you search by voice, it will be better, not only because the model is better, but also because the hardware is better. At the same time, we see a jump to very new chipsets. So this is NVIDIA A100, and these are chipsets that are less energy intensive. I think this is fantastic. In Amsterdam, we have this whole cloud center which runs on these particular chipsets, very powerful, and they float in oil, right? So if you go to the basement and you go to those data centers, I actually put my hand in the oil and you can feel the oil is a bit warm. Because what does it do? These chips generate heat, right? And with that, they also impact, for example, climate change. At the moment, cloud computing is taking roughly 1% of the global energy already, right? So this is quite a significant thing. And these new chips, they float in oil. They heat up the oil then heats up the water, and the water then heats up the building, right? So they're trying to make this in new ways that are more climate sensitive. You also have lots of new edge devices. An edge device is a sort of a mini computer that runs the AI computation, typically a signal detection, for example, runs that locally. So imagine you have an airplane and you want to have a predictive model that will tell you if the airplane, if the wings are going to fall off. Then probably you have sensors in the wing that detect the vibration of the wing. And if it becomes way more, then your system should say, hey, there's something wrong with this wing and the airplane should go down, right? That computation could be done locally. And that means that this device, which is like a credit card size, will be present inside that airplane wing. And the same, of course, will be true in your phone, in your camera with facial recognition at the door. So there's lots of these edge devices now that are actually mini computers that do some of these simple AI algorithms locally without using the cloud. And the nicest example is the Google Pixel 6, right? So this phone is really, really amazing. I'm not working for Google, so this is not a commercial, but it's really amazing when it comes to, for example, voice recognition, right? Way better than the stuff that I've used so far. Why? Because the chip inside, you can see it here on the right, the chip is AI optimized, right? So that's an example of where's his hardware game going. Then to models, right? So most people, if you ask what is AI, then they'll probably say, well, it's a model, right? And we'll look at what that is. And a question to you, if you build a model, what actually takes up most of your time? So imagine you're going to build a model and maybe you want to predict, the price of a house. What is going to take most of your time? So put some guess, training it, optimizing it, the coding part, the coding part is everything. Software, data, coding, data gathering, planning, selecting the accurate algorithm, data mining algorithms. Okay, so the people who mentioned data collection and data cleaning are correct, right? So by now, the world is so optimized in the AI space that it's very easy to select the right models. There's lots of platforms that will actually give you lots of models right away or lots of tips right away on how to do it. So you have lots of low-code platforms. So the actual work is in the data collection and data cleaning, right? So typically, that is the real thing that is hard to do. And the steps are the following. So without going through the whole thing in depth, but 80% of the work is in making sure you have the right data. It's very, very hard, right? Even in a company, companies typically don't have the data that you actually want for your model. And then making sure that data is prepared, it's cleaned up, it doesn't have lots of weird dots and commas, etc., capitals that you don't need. Then you choose a model, typically quite easy because we know which models are currently performing best. If you do your research, it's pretty straightforward. You train the model, also not very difficult with today's hardware. You evaluate the model. That can be difficult because you have lots of different metrics you can use to evaluate how good the model is performing. And you tune it, right? And so you do a couple of rounds. And in the end, once the model is done, you can use it for inference. So you ping it and you get a specific prediction from the model. So this is the chain, right? This is how that system works. At every step of the way, if you look you see this as like a factory floor, you see people now tweaking every step of the way. So this in the beginning was a lot of work. It would take you months to get data and then to clean it, etc. Now, in many cases, it can actually be very, very quick. There are lots of existing data sets, there's lots of existing models you can borrow, and through transfer learning, sort of only change the last 2 layers in your neural network, and then it's actually very, very quick, right? So you have to see this as something that took a long time in the past, and now with all the bright people working on this, now it's actually way, way faster, unless, of course, you're trying to build a complete new thing. And here's an example of how that is being changed. So someone asked in the beginning, are we going to do Python? And I said, no, there's no Python. We could, right? But Python by itself has lots of different dimensions and packages and libraries, etc. And the way that most of these platforms are now moving is they're trying to make an AI model, the creation of an AI model so simple that anyone can do it, right? So we call that democratization of AI. So whether you're an accountant or whether you're a psychologist or whether you're an engineer, you should be able to make that model. And how do you do that for people? You do that by simple no-code or low-code interfaces, right? You drag and drop. You have lots of existing databases. You drag them. You can see here on the left, data CSV file. Then this is the preparation, right? And technically, you can just draw the different steps you want to see, and the coding is already done for you. So this is the future of AI for most companies. You don't need to code everything. It will be a low-code or no-code platform. And why is that great, right? It's great because you can train way more models and try way more things with more people. And then, of course, you have a higher chance of succeeding. I still want to go, even though that is the future, and even though most of you will be working with it, I think by the time you work in AI, I still want to jump to models a little bit, right? And I want to give you a sense of how they work. And we're not going to go into transformers and all the latest, very difficult ones, but the basics I think is useful. And the basics of most models today are neural networks, right? And a neural network is modeled after the human brain, which has neurons and connections, synapses, etc. So that is the analogy that you should see here. And this is how it works, right? So you have a neural network. The visualization here is on the left. And the way the system works is there's input data coming from the left, and there's a prediction coming out on the right. So every AI engine almost always is essentially a prediction system, right? So it will predict whether this is a cat or a dog. And we know as human beings, this is a cat. And we call that classification, right? A or B. It can also predict something which is more continuous, like a price, right? Could be from 0 all the way to 100 million. So we call that regression. But both of these things are prediction problems where AI is really, really solid. And you train that with labels, which we call ground truth, right? So you have the actual labels. For example, as a human being, I could say this is a cat. So that's the label. And I could say this price in Amsterdam of the building is 1 million. That's the label. So what you do is you get all the input features that you get for the house. Let's say it's the size, it's the location, it's how well is it maintained, you name it, right? Same as what you would do as a human being. How expensive is the house? You would probably look at a couple of different factors that you understand and then try to come up with what you think is a reasonable price. The difference here is the AI model can handle millions and millions of those different dimensions. So if you just throw a data sets, it will handle those different dimensions. And it can go deeper than that. You can see here in the middle of this network, it's not an input layer and an output, but it's an input layer and then layers in the middle. And this could be one layer, it could be 100, or it could be 1,000 layers. And here's where the complexity comes from, right? Because this first element that you selected, maybe the size of the house, will interact with every other element in the second layer. So then it gets a weighted, it becomes a weighted feature of those different things, right? So now the complexity gets higher. One layer down, it's a weighted, or it's a combination of those features. And all of those different lines have weights. And what you actually train in a neural net is these weights that then allow you to make a better prediction. So again, you're trying to predict the price of a house. It's called regression, right? You know the price is 1 million. Your model says it's 800,000 euros, so it's off by 200K. That means there's an error, and you retrain the weights between the cells until your model gets the 1 million correct, right? So that is the essence here. So why is it special? Because of two things. The feature engineering, selecting what kind of data elements are most important, is done by the AI system. So the weights are actually calculated by the AI system. It can handle unlimited amount of features, where human beings can typically handle 5 or 10, but not much more. And this system will update itself if it gets better data, right? So this is a loop that can go on continuously, where you don't have to re-engineer that thing again. So that is the essence of neural networks. Then let me show you this in practice, because we've seen enough slides. I want to show you how this works with what we call the hello world for AI engineers or machine learning engineers. MNIST. MNIST is a data set used by the Postal Service in the past, right? And MNIST is, you classify a written number 1 to 9, right? And what does the model do? It tells you if the written digit is a 1 or a 2 or a 3. So it's a classification model in 9 different elements. And you can see it here happening, and it's a neural network. And I think you will appreciate the richness of the complexity of the calculation behind it. Have a look. So those are the written digits by human beings on envelopes, on postal cards that you sent. And here's an example of how that network could look like, right? And for your information, this is a very simple network. It only has a few layers, right? The networks we use now have billions, hundreds of billions of these neurons, and this is only in the thousands. So it's a very simple version, but it tells you how it works and what the essence is. It's predictive. It tries to predict what is the right number here, and it does that with a neural network where the weights are trained and the numbers would have human labels, right? So the human would do that first, and then the model would learn from the labels. Okay, so I hope you got the essence a bit. Let me check the time, by the way. So we still have some time, good. But for those of you who are in the engineering domains, I think you're probably thinking, okay, this is great, but this is actually 20, 30 years old, right? So we can already do this for a long time. And if you're thinking this, then you're right? So this is just a very basic example that is nice to train your first neural network on MNIST or on cats and dogs. But we have moved beyond that, right? Now AI is now a booming market, as you know, and with lots of funding going in, with lots of PhDs, lots of really smart people. So I want to give you a couple of examples of where we are now. And I think this is going to be more interesting than the MNIST story. So the first thing is, I mentioned AI is not good at complex goals, right? For us as human beings, there's always goal complexity, right? Do you want to be an accountant or a dentist or a psychologist? Do you want to spend time with your kids, with your wife, or do you want to play soccer, right? So every time you have multiple goals, and lots of the complexity in life is that you have lots of different options to choose and then to optimize for. So that until recently was really difficult. Every model would just optimize for one particular thing. But now we're seeing the first models that can actually do more complex goal optimization in 3D, like we do, and sometimes even with adversaries. So here's an example of a neural network, as you know, that's trained to optimize to win a game, but the situation is way more complex than the MNIST example.
On Earth, the simple rules of natural selection and competition led to the evolution of increasingly intelligent life forms. Today, we ask if comparably simple rules and multi-agent competition can also lead to intelligent behavior in a new virtual world. These agents are playing hide and seek. These agents have just begun learning, but they've already learned to chase and run away. This is a hard world for a hider who has only learned to flee. However, after training in millions of rounds of hide and seek, the hiders find a solution. The hiders learn to use rudimentary tools to their advantage. By grabbing and locking these blocks, they can create their own shelter. The seekers are locked in place for a brief period at the start of the game, giving hiders a chance to prepare. Even so, the hiders must learn to collaborate, accomplishing tasks that would be impossible for any single individual. The hiders are not the only ones who can learn to use tools. After many generations of failing to break into the shelter, the seekers learn to jump over obstacles using ramps. However, after many millions of rounds of having their shelter breached, the hiders learn to take away the primary tool the seekers have at their disposal. Note that we did not explicitly incentivize any of these behaviors. As each team learns a new skill, it implicitly changes the challenges the other team faces, creating a new pressure to adapt. So how do agents acquire these skills? They're trained using reinforcement learning, an algorithm inspired by the way animals on Earth learn. The agents play thousands of rounds of hide and seek in parallel for many days. They train against each other, as well as past versions of themselves, using an algorithm called self-play. Co-evolution and competition on Earth led to the only generally intelligent species known to date, humans. While this world is far less complex than Earth, we have found evidence that simple rules can lead to increasingly intelligent behavior from multi-agent interaction.
Okay, so what you saw, I think there is a nice application of a very similar thing. So he mentioned this is reinforcement learning. Reinforcement learning uses it is modeled after how humans learn in real life. So this is a system with rewards, right? So you can do a certain task and you get a reward for it, and that means that the task was successful. In this case, winning the game gives the little puppets in the game a reward. So then they try to maximize that reward in the algorithm. So they will try to learn the best behavior to maximize that reward. And what is the brain of those little agents? It's a deep learning network that you just saw, right? So it's a neural network. But in this case, they're in a 3D environment and they're actually learning the patterns to win the game. But way more complex than the MNIST example. The second thing that I want to show, because I mentioned classification and regression as the main use cases, and I mentioned that, hey, this is all about prediction, which is still true inherently or philosophically. But now it's actually changing in the user experience, right? So it's changing in that AI is not only helping with house prices and helping with classification of pictures, etc., but it's actually creating lots of content. So you have lots of music albums already that are created by AI. You have lots of artwork created by AI, sometimes sold for huge amounts. You have videos created by AI. So we would call that creative skills. This is not the same as a predictive model. For us, that is creation, right? And here's an example. This is the creation of images where you can literally say what you want to see and the model will then create it for you.
Have you ever seen a polar bear playing bass? Or a robot painted like a Picasso? Didn't think so. DALL-E 2 is a new AI system from OpenAI that can take simple text descriptions like a koala dunking a basketball and turn them into photorealistic images that have never existed before. DALL-E was created by training a neural network on images and their text descriptions. Through deep learning, it not only understands individual objects, like koala bears and motorcycles, but learns from relationships between objects. And when you ask DALL-E for an image of a koala bear riding a motorcycle, it knows how to create that or anything else with a relationship to another object or action.
Okay, so what you saw there, and maybe you find it impressive, maybe not, but for me, this is hugely impressive, right? Because you give it language. Language is not the same as pictures, right? It's drawing. It understands your language, and then it actually draws whatever you said. So if you want to try this, there's lots of easy ways where you can explain this or try this yourself. I would recommend DALL-E 2 or DALL-E 2 Mini, which you can quite easily try on Hugging Face, or Midjourney. And then Midjourney is, you can literally, you don't even need to code anything. You can try it and be part of the Slack channel, and you can give it the prompt in your Slack, say, I want to see this, this, and this, and this, and this, and you can see what the model is generating. So Midjourney, I tried it before the session. This is what it gave me, right? So I asked, can you draw my dream house in the mountains? This is what I got. It's a little bit confusing, but not too bad, right? Can you draw the AI system behind chemo? Well, this is what it generated. And can you draw my daughter in 2050? Right. So luckily it became a very beautiful, very sci-fi lady. But this is an example of, generating art. If you consider this art, but at least it's quite creative. It's new stuff. And it's becoming available at scale, right? You don't need money for this. You can literally try Midjourney for free, and you have generative AI. And the last thing I want to show you is, because a lot of us associate AI with something you can talk to, right? Something that understands you. So the last thing is I want to show you the latest version of conversational AI. So it is a bit like Siri, right? But it's a system that understands language and is able to speak language. And the difference here is with Siri or Amazon Alexa or whatever you've tried, is these things were pretty much quite robotic, right? It would be, and you would hear it's not a human being. And the latest models, they would actually train also on what we human beings do. We put emotions into text. We're breathing sometimes, so you can hear stuff like that, or you have pauses, right? So these newest data sets also have these elements, and then suddenly it becomes very, very human. So have a look.
Hi there. I'm not really sure how to start this. I wanted to talk to you about something we're all looking for. I want to talk about love. I get it. It's kind of awkward. How do you connect with another person? Finding that common wavelength and really connecting. A connection that could turn into love. What could I do to make you fall in love with me? Would you need to feel my breath against your cheek? The soft touch of my fingertips? Laughing at that face you're making right now. I mean, I think I love you. I love you. Is all you need to love me in return the sound of my voice? Well, I hope that's all you need, because that's all I have. What you're hearing me say was never said by a human. It was generated by a computer. I'm not real. I was never born. And I will never die, because I do not exist. I know. Sounds like something out of a movie, right? But it's real. So, could you love me?
Okay, so I hope you found that impressive, right? So what you're seeing there is it's a language model that produces language, and it sounds, at least in my experience, this sounds pretty real to me, right? So the emotions are there, the pauses are there, the breathing is there, and suddenly now this feels a bit like the movie Her. If you haven't seen it, then you should, right? So this is an AI that you could actually almost build a relationship with, and that's of course how they made the movie. So I saw a couple of people were reacting to the generative AI part, right, where you can have pictures generated, and yes, you could see if you could mint those pictures as NFTs, right? But the size is quite limited, so you cannot produce very large pictures with lots of pixels. So there are a couple of restraints. But I think your hint there is smart, because the logic that if you can have art or music or anything that is created by AI, of course you can have that created at a large scale. You can have your computer running millions of those images a day, and you select the right ones. And then the whole creation of art, the way we know it, right, with artists that have a lot of time and need brilliant insights, has become quite different, right? So one note before we look to the future, what's coming next, right? There's something called AGI. So if you start reading about AI, lots of people will write about general intelligence or artificial general intelligence, which means that's the intelligence that we have as human beings, where one brain can do lots of different things. It's conscious, it has emotions, it can drink coffee, speak in a webinar, read a message on the phone, all in the same brain. That is not really where we are going, right? At least, or maybe we're going there one day, but it's not where we are right now. So the current AI models, they are still very much modular. So you can have a model that is good in language, or particularly speaking language. There could be another model that's really good in natural language understanding. Another model is good in cats and dog classification. So these models are separate models, right? There's no way to turn that into one. Although there are the first attempts to make a model that can do multiple things, and DeepMind published the first version, But at this point in time, there is no AGI, right? And I'm quite skeptical that we see that in the next 20 or 30 years. But if you believe the experts, most people think it will at some point come. And the timeline might be 20 or 30 years away if you believe the average of the expert predictions. Okay, quick note on countries, and I'll keep this brief. It's a topic I always really enjoy. So between nations and also continents, EU, China, India, US, there's a huge competition going on. And if you read the news, you probably notice this. And what everybody's trying to do is build the biggest, most powerful foundation model, right? For example, a very large language model that can do translations in 200 different languages. Once you have those main models, you can build lots of models on top of that. So you technically use the main model, you cut off the head of the snake, the last few layers, and you train it for your particular purpose, right? So maybe you want a language model that is really good in answering questions about AI. You take the full language model, but you cut off the last part, and then you train it on AI questions and answers that you can find. And here you go, right? It's the same what we did in Kimo, in the chatbot. It can answer lots of questions, and we took that model from a different place. So that game is going on, and you can see that countries are now trying to invest, and companies are trying to invest in who has the largest, most powerful language model. We started with models with literally a couple of million parameters. Now we're at models with 1.75 trillion parameters, right? So these models take 10 or 20 or 30 million to train for a single job, right? And most likely you will need to train it a couple of times again. So this is becoming a big power play, right? Who can spend that money? How's the government supporting that? Is that done by a private firm or is it done by a government? And does that matter, right? So this is going on sort of in the news, of course, as the geopolitical race between countries. And you can see that also if you follow politics. This is the number of times AI was mentioned in US Congress, until let's say 2017, almost no mention. And then suddenly that skyrocketed because they realized this is going to be a very important moment. Lots of companies in Europe are trying to now protect their companies from being bought by other players. Both China and the US have framed the war to win the AI race as existential, right? So if you don't win this, you lose. So you need to be first. And over 50 countries have announced an AI strategy, right? So this is a very big geopolitical topic with lots of political interest because it is extremely relevant. What's next? We have 2 more minutes. So let me share that and maybe answer 1 or 2 questions. And also I will tell you what I think will be next, right? The next maybe 12 months, and this is going, I told you in the beginning, it's going really fast. So what I think we'll see is a very strong focus on data quality. Until now, we've done a lot of other stuff. We've built very big compute centers. We've built better and more efficient models. But one of the key things we're still lacking is making sure that this data collection is easier, because it's actually very, very difficult. And I urge you to try it. For most use cases, you'll find that the data is hard, right? And if you have data, it's of low quality, it's messy, it's all over the place. So there's going to be a big push on platforms that can provide really easy, really high quality data sets where everything is about, if the data set is there, the model is pretty easy. Of course, you're going to see lots of specialized silicon. So you will see lots of companies like GraphCore, Samba Nova, already some have over $1 billion in funding to make better specialized silicon that can run AI applications faster than we do now. Hilo is a nice one for edge computing. Google building their TPUs and putting those kind of things into their Pixel phones, right? So lots of specialized hardware, different than what we're using now, which is more general purpose. You're going to see lots of virtual twins. So every product, a car, Tesla car, or a factory will have a virtual copy of that product, right? And with that virtual copy, you can do lots of different optimizations driven by AI systems. So expect anything you buy in the future to have a virtual copy that sits in the hardware of the company. For example, the Tesla cloud center, right? They will have a virtual copy of your Tesla car. The models will become multimodal. So the first models that can handle text, images, and voice at the same time, where in the past those were completely siloed, are already appearing. So you'll see the first models in production available for you and me, where you can give a text response and it will give you a picture back, or you give a picture and it will give you voice back. It can handle all those things like we human beings can. And of course, we'll see lots of models that are more efficient than we have now. And that is important because they need to run, in many cases, locally on a local device, right? So that is what I think will come next. To give you a sense of that multimodal learning, I want to mention one example. The way Mercedes is going to have their autonomous cars is together with NVIDIA. And the first launch, I think, is next year. It's called the Hyperion 8. So it's a Mercedes car with an NVIDIA AI system inside. And that system uses 14 cameras, 9 radars, 3 LiDARs, and 20 ultrasound devices, right? So for that single AI engine to work, there are lots of different sensors, lots of different data streams that come in. And then, of course, it needs to predict how the car should drive, right? So that is this multimodal learning where all of these different data streams come in to the same engine. Okay, we're at the end. Let me take 1 or 2 questions. So I see from Dr. Saima Zia, how do you see the role of AI in human resource management? Dr. Saima, it's already really for large scale there, right? If we hire people in Chemo or in any other company, and I do it on LinkedIn, I get 5,000 resumes, but LinkedIn will give me the top 10, which is obviously an AI system, right? Most companies use AI filters on their resumes to hire people. And lots of other ways. There are even systems in place where they will ask you to write a little paragraph, and they will see how well you understand certain topics. And also if that paragraph matches the style and everything. Oh, sorry, someone is calling me. Of the company, right? So it's they match your style to the company style, then they see if they can understand your how well you understand something from the text. So lots of different applications in HR. Last question. Is starting with data analytics a good thing to do? I think that's all the way back to the beginning. Yes, that's a very good thing to do, right? So please do start. That's the whole purpose of these webinars. Data science, data analytics, AI, very close. But this is where the jobs of the future are, right? So definitely do start. And I hope you will enjoy it. So far, I hope you had a good time. Not all questions answered, but I hope you learned something, and I hope to see you again. Thank you. Have a good night.